Okay, thank you. Good morning, Chair. Good morning, everyone. I'm Qinxin Chu from the South China University of Technology in Guangzhou. Yeah, it means yeah. The title my talk is Decoupling between the MIMO antennas by conversational network method. So in this talk, there are the 4 parts. First, we'll give an introduction, just to introduce some background and motivation in my research work. So my research just on the MIMO technology. We know in the 5th generation mobile communication, the MIMO technology is a very important the technology. So for this method, you have the 2 advantages. First, improve the data transmission rate, and second, improve the signal noise ratio of the data. Just from the Shannon the equation. Currently, most of the MIMO technology have many applications. For example, in the base station, in the mobile terminal, or the mobile phone. This picture just shows the development of the mobile phone, the antennas. We know in the 1st generation, the mobile phone is very simple. Only the multiple antenna like this. Yeah, like this. No, sorry. Yeah. Okay. Yeah. Only the very simple the multiple antenna, just placed outside. In the 2nd generation, the antenna inside the box of the phone also have 2 the band the antenna. In the 3rd generation, many antennas inside the mobile phone, like so many the bands. In the 4th generation, the MIMO antenna first introduced the mobile phone. Currently, we know in the 5th generation, we so many like this picture, so many the antenna must be inserted the mobile phone. So have many the band. Beside the 2 generation, 3 generation, and 4th generation antennas, also have the 5th generation antennas, especially for the mobile MIMO the antennas. So for so many antenna placed in the terminal the terminal phone. So a big problem brought is the monocoupling. We know the antenna just for the radiation electromagnetic wave. So many antenna tightly installed with a common reflector and rhythm in the typical space. So the coupling is very seriously affect the performance of antenna. So for the effect can include the first mismatching. So antenna the performance, how many reflect the wave, so the towards and forward, and also isolation, deterioration, so the electromagnetic interaction often appear, and also radiation pattern distortion. Also, the patterns change a lot. So first, can say the watch is the matching and coupling. When two antenna is closing placed together, so we know that following the Faraday's law of electromagnetic induction, any conductor in the EM field will produce induce a current. So when the first antenna 1 is excited, antenna 2 will produce an induct current when they are so close to the place. So match and radiation antenna 1 will be interfered by the antenna 2. So first, inductive currents into the circuit connected with antenna 2, which causes the reflect. So causes the mismatching, causes the isolation become worse. And meanwhile, the induced current on the antenna 2 will radiation again, so and interfere with the antenna 1, resulting the distortion of the patterns of the mismatch of the antenna 1. There are the coupling way for the following between antennas. First kind is just the coupling in the space. So in this space also include the near field, inductive near field, also radiation near field, and radiation far field. And another way on the ground. So in the ground also there is two kinds. First, the current on the conductor ground. Also, and another the way is just the surface on the substrate, the interface of substrate. So how to decoupling? I think there were two ways. Firstly, just partition, just to not allow the field of the exciting antenna to reach the unexciting antenna, or the induced current is too small to cannot affect the exciting antenna. Another way, just neutralization. Also the cancelled. Also we can use some method to introduce a new coupling ways to neutralize the original coupling. We also can use some method to introduce the positive elements to form the opposite inductive currents on the induction antenna, which cause the EM field generated by the inductive current to be cancelled or to be neutralized each other. So now let's see some current the decoupling techniques. First, we introduce the DGS, just a defective ground structure. This also similar to the filtering. So you can see this picture. This antenna is another antenna. Just we cut a slot here, between the two antennas, so we can have the decoupling in the some the frequency. So in this the example, we can the isolation can be improved 5 dB. We also can use the more than one the slots on the DG structure file, so we can get the high the isolation improve, and also the slot wideband. Also, this is the work by my PhD students. This work published in 2011. So this just for the mobile phone. Between the two antenna, we set the slot in the ground between the two elements, so we can get the wide band the decoupling, get a good the isolation. Also, this also the cutter slots the DGS, but this slot is a solder like this. So this first can improve the isolation. Also can this the DGS is also the part of the antenna, so also can improve the radiation of the antenna. So this in this work we can find have two slots of the antenna, so can get the two band the isolation improved like this. So in this work use also the two kind of the DGS or the slots. This first for the lower frequency the decoupling, and here have a two narrow slots, just improve the high band isolation. The second method we call the reflection element. The vision is very simple. For the two antenna with the coupling like this, so the performance become worse. If we insert the reflect elements, so antenna just radiation in different direction, so between the isolation get the good improve. For example, this work just use a T-shirt the reflect element. Why use a T-shirt? Just want to improve the isolation in dual band. So if we use only one, the flat, we only improve the isolation in one band. So use a T-shirt. The reflector can in two band improve the isolation. Also, this also the work of my PhD student. So use the first use this kind the reflect element. So use this structure also have this the slot. Also use this slot to improve the isolation and also the matching. So this work published in the 2012. This is the radiation. We can find the two the antenna radiation direct two different directions. This or this direction, this direction. So isolation can be improved. Also, this also my student work. We propose the two element MIMO antenna for the terminal the phone. So this is two elements. We use first use the reflect element. Also use the DGP. So improve the isolation very good. Also, this two element pattern radiation pattern. In this work, also use the reflect element. Have two kinds. The long reflect element just for the lower frequency band, so improve the isolation. And short the reflection just for the high band. So the third method just a passive element. This is similar to the reflect element, but they not reflect all the wave, just the transmission of some of the wave like this. So this is the original coupling. When we insert the state element, we can get another coupling wave. So when these two coupling waves have the same the magnetic and just the outer phase, so can cancel the coupling like this. This two dipole. When insert this kind of the element, we can see can get the good decoupling performance. Also use this work. This is one first the antenna. This is another antenna. Just a PFA. Here use the perceptual element, so can improve the isolation. Then this in this the work we can just the radiation the antenna just the two slot antenna. So this just here is the perceptual element. So can improve the isolation. This antenna another phase. And also the third method is called the diversity. In diversity method also have two kinds. The first polarization diversity and the pattern diversity. You can see. This is just just polarization diversity. This is three antenna. This is first. This is the second, and another phase have one there. So this is three antenna just the vertical. So have just a difference in the polarization. So have a good isolation. Also this work just three Yagi antenna. But the radiation direction just the vertical. So this is a pattern. So have a good performance. This also the work my students. Also the four element the MIMO antenna. This 1, 2, 3, 4 per element. So this the antenna just have different the polarization, so have a good isolation. So this is the patterns. Also, it's also the work my students that they use the for the H shirt type of the antenna like this. This is one antenna. So 1, 2, 3, 4. So have just the different the polarization. So also have a good performance. Which is published in 2030. This is direction. Also in this the work we can see this is a the dual band antenna, but the direction this is okay. We can see this have a different the pattern. The polarization just is vertical. Okay, this work. So the antenna is a ring antenna, but this direction is here and like this. So when set the mobile phone like this, it's just 8 elements, but the radiation have a different equation like this. This just this the pattern direction. So also have a good isolation. This the patterns. Also in this the work we can see this is just 2 elements. This is the first element. This is the second element. So this is just a 4 element MIMO. The first this is the antenna. We can see the polarization is this direction, and the lower the antenna the polarization just this direction, so has a vertical polarization, so have a good isolation. This also this is similar. This has a 2 band. This for the high band. This for lower band. And this direction radiation this direction and this like this. So also have a good issue. Also have another method just proposed by Professor Curly Wu. He called this work the capacity loaded decoupling. This just the IFA, the 2 IFA antennas. So they can connect the capacity. So because this is the capacitive proposed another the coupling way, so can cancel or the neutralize this original the coupling way. So how get a good decoupling and a good organization. Also, this is similar work from here. They use the shorthand the line to get the capacitive performance. Also, the method of decoupling network. Just in this work, just insert the coupling the network to cancel the coupling between the antenna. So also have a good isolation. This is for the 2 band. 2 band decoupling network. Also, when the many the antenna close to get the multi-element MIMO antennas, so can use the many the decoupling network like this. So also have a good performance. Also use the this is just a decoupling network. Also, a method we call the decoupling surface. So this is a two antenna. So insert just FSS between the two antenna also can get the good oscillation. This is just the measurement results. The last one is the method we call the neutralization line. Also very simple. When we have the original coupling, we only insert the neutralizing line. When this the coupling is similar magnitude, but have the out phase, so can the coupling can be cancelled, so isolation can be improved. Like this two antenna, very simple. Just introduce the line, connect these two antenna, so get the good isolation. And also in this the work, this antenna, this another antenna. Just when the monopole, just introduce this the neutralize like this neutralization line. So have a good the isolation. Also this the work my students they use a T-shirt the neutralization line like this, so can get the two band the actually through, so get a wide band the decoupling. Also this also the work of my students. This is two the compact the UWB antenna. Use also very simple this neutralizing line. Also use the four slots, so get also the wide band the decoupling. Also this another the neutralization line. This is this work I think very simple the decoupling network, because this neutralizing line just on the microstrip. So this neutralization just use the first is the inductance the coupling, and the inductance like this. Here is the capacity, here is the inductive, so we can get the wideband decoupling. Also, this is use like this the inductive the neutralization line. So also get a good isolation. So now we should introduce the work my students recently. This is just the work by my master students. He have generated in the July, and working in Huawei company. We just proposed the new method we call the conversational decoupling network. We consider the coupling between antenna just because the original coupling network. So when we add all the insert all the use the conversational decoupling network, like this. If we control the decoupling network, the performance of all the purpose, we can get the good the decoupling the performance. So this work, the type is free. You can use the lamp company. Also can use the neutralization line. Also can use plastic branch, etc. So, for example, we give some the research example. So we design our wideband MIMO antenna for the mobile phone like this. This is just the coupling, the PFA antenna. Why called the coupling PFA like this? Not a direct connect antenna, and just also use the cap to connect the antenna. So I had our wideband because this work just for the 5th generation application. So the operating band just from the 3.3 to the 6 gigahertz. So the antenna have a good performance. Like this. Now, first, we put this kind of antenna in this style. So the difference between the antenna just have a 10 millimeter M. You can find for this the 2-element MIMO. We find the performance here. Okay. This is the isolation is not very good. Only the 13.5 dB. This is the direction. We will also find the radiation patterns also can get the exact the performance, the effective. Now we introduce the auxiliary the port here. This the port the auxiliary port, so we can get the coupling the scattering purpose like this. We find in the lower frequency here, just the inductive coupling, and in high frequency, here, we find this the capacitive the decoupling, the coupling. So we want to use two different the neutralization line to neutralize the coupling. So first we use the inductive like this, just a T-shirt neutralization line. We find this inductive. So the inductive the performance. So when you say in the high frequency, the isolation can be improved, but in lower frequency, the improve is very small. Also, this just current distribution. This is the measurement. Also, we introduce the capacity neutralizing line like this. This is just the decoupling. So we can find in lower frequency get the good improvement. Also can the performance. So this just the coupling neutralization line. So this is just a measurement. Also, we can use the mixed coupling neutralization. We just use 4 elements. First, we use inductor. So the inductive coupling neutralizing line. And the second, use capacitor. Then use the inductor. So we find for this structure, we find we lower and higher frequency, we also can get a good isolate improvement like this. So this is the current distribution. This is the measurement. So we can find in lower and also in higher frequency, in all get the good decoupling, performance decoupling. Okay, finally give the conclusion now. So in this talk, the mechanism of coupling decoupling techniques have been analyzed. Also, a new decoupling technique we call the conversational decoupling network has been proposed. An ultra-wideband antenna, ultra-wideband antennas for 5 generation mobile phone terminals are proposed, and the conversational decoupling network has been applied to design wideband MIMO antennas. Thank you.
Thank you, Prof, for the wonderful sharing experience. I can see you're talking about coupling between, especially for the MIMO antenna. So basically, is there any question? Anybody want to ask questions?
Hello.
Yes, Azrimi, do you have any questions?
Yeah. Hello. Hi, Professor Chu. This is Azrimi from Malaysia, one of the committee members. Thank you very much for the very exciting and interesting talk. I have one very general question. Okay. When you look at the techniques or methods that you propose, I mean, you show from the literature, there are some techniques. If you look at the response of the coupling, it's behaving like reflection, I mean, it's behaving like reflected signal. And there are also some techniques which also just reduce the level of coupling. So, do you have any preference which technique is better, or is it depends on application?
I'm sorry.
Can you please comment on that? Thank you.
I'm sorry, I cannot hear you clear because of the noise. So the chair, do you understand the question? You can.
Yes, it's also noisy from here. Azrimi, you please drop down questions in the chat box, please.
Thank you very much. Okay, sorry. Thank you. I'll try to jot down because it's quite long.
Yes, please summarize it.
Not clear. Okay.
Okay, Prof, I will try to ask. There's a few questions from the chat box we received. Okay, basically, Muhammad Haizal Jamulin asked, in a MIMO antenna design, we want antenna to be compact. So we choose inter-element spacing very small, which is less than 0.5 lambda. Among the decoupling technique, which is the best for this small inter-element spacing?
What? You mean how to design a compact antenna?
Yes, basically, he asked, among a few of the decoupling technique that you show to us, which one is the best for a small inter-element antenna spacing?
Yeah, you just have to design a small terminal antenna.
Yes, yes, in the MIMO antenna design.
Yeah. For example, in this structure, this antenna is very small because this is only the one or two millimeter. So for most of the terminal antenna, we want to get the compact. So we compact also the wideband, you know. So we usually to use the PFA antenna like this PFA. This is just a PFA antenna. But the conventional PFA antenna also the large and narrow. So we use the decoupling because this is the gap, so we can introduce the capacitive. So capacitive can decrease the antenna length. Also can get the wideband. So just this is the key the design.
Okay. So, Prof, we also received a second question from Hamizan Yund. Decoupling, I think it's about similar topic as well. Decoupling technique will increase the distance between the multiple antenna. How do you tackle this situation for very small design?
Very small design. For what very small design?
Okay, they ask you how you can actually tackle situation for small antenna design because normally decoupling technique will increase the distance between the multiple antenna.
You mean the distance is very small? So
no. Basically, he asked normally for a multiple antenna, the decoupling technique will increase the distance. So how do you tackle the situation? Or is it your decoupling technique able to maintain the same distance?
Because the most of the distance between the antenna just from the application. We design this antenna. Most is used the mobile phone. For example, for the Huawei company, for the Oppo company. So the distance is just from the company. They call me just use this distance, then you have to decoupling. So distance is like not set by me, just by the company, just by the application.
Okay, understand. So it also depends on the company design requirement, right? Okay. So we also receive the third question from Azza. I may miss this information, but may I know how much decoupling in dB is sufficient for a wireless system? What is the impact of bad decoupling to the system performance?
You mean the system how to decouple?
Yes, basically he asked how significant basically is the decoupling in wireless system. She's actually talking about the impact of bad decoupling to a system performance, especially for wireless systems.
Maybe I use this example that let me show my idea. So for the multi-element MIMO, the decoupling is very difficult. For example, there's two elements. We most of the paper or some method tell us just the decoupling two elements. If only the two elements, we can use this method is okay. But when three elements, use three elements. You run the technique is very successful for this two element decoupling, but this method cannot use here because this decoupling meanwhile in the same time the decoupling between the elements, this coupling becomes poor. So we must use another method, just have a different method to decoupling this between these two elements. So we use an inductor. Here just use a capacitor. So maybe for the many multi-element MIMO antenna decoupling is difficult.
Okay, Prof. So basically, maybe one more questions? One last questions? If not, maybe we actually can go for the next keynote sessions. Thank you, Prof, for your very informative